Good morning to all. I will present the topic cables and the suspension bridges. This is a fourth unit of essay, structure analysis 2. So, what is a suspension bridge? What is will be suspension bridge? So, one of the several type of the bridge design is used to longest span, used for the longest span. The cables means suspended the roadway. So, towers means stabilized wire cables offer the little support. Anchorage is key to the structure. Mass that keeps a cable tight gives the bridge structure. So, this is the anchorage. Anchorage is next one is this is a suspensor cable, suspensor bridges. So this is cables. This is a hangers or stringers. So this is towers. This is deck slab, and this is anchorages for cables only. So anchorage supports. So this is the suspensor bridges with the anchorages and without anchorages. During the engineering contributions to the engineers farmers for the American special features. So next one is the use of steel. It's in the development of wire cables, the spinning, the assembling the heavy cables in the air, advancement of the spring trusses. The trusses are triangular structures that adds strength not weights, and then Picora falls in the 1855 to 1897. So the total feet is 825 feet. The suspension five ways. This is the first bridges. During the bridges. And the longest of the times. Total feet is 1595 in 1983 and 1883. The other famous suspension bridges. Obviously, we have five bridges. So this is Japan. Place is Japan. 6,529 feet. The longest is suspension bridges today. So the top 10 bridges in the world by length. The total length is 26,372 feet with the 68.6 feet. Height is 522 feet. The longest is 3,800 feet. This is the longest bridges. Ampastar bridges dimensions. The total length of the 7,500 feet, 2.286 feet. The longest span, 1,850 feet. The meter is 564 feet. The general, the general contractor contractor wants to see a scale model of the bridge. Before the begin the construction, you will have limited the workspace. You will need to scale the feet down to workable unit. In this case, you will be 1 inch to equal 50 feet. The total scale length and the scale span length and total scale height, the total scale of the road width. So this is the suspension cables and the bridges. Mm. So first of all, the cables are 20th century. 20th century, a large number of markable suspension bridges were constructed in North America, in Australia. There have been landmarks of the certain cities of these movies. The cables in the form of wire hoops or parallel wires joined with the clips are used in the suspension bridges and the transmission towers. So, suspension bridges are used to roadways of the spans more than 200 meter and light traffic ways of a span more than 300 meter. So, and the cable's maximum shag or tip of the cables varies from L by 10 to L by 15, where L is the horizontal span. So, the tip of the cable is T. This is the This is the cables of the suspension bridges. And then the cables So for the examples of the cable supported A and E is loaded shown in figure. Commute the reaction components and the tension in the different portion of the cables. So solution. The consider first one is the consider the cable as a whole in equilibrium and applying the conditions of equilibrium. The sum of the force Fx equal to 0. So reactions are minus Ra into X, Ra into H plus ReH equal to 0. So ReH equal to ReH equal to H. This moment about A equal to 0. So find out the values of Re in the total distances, total span of 8 and horizontal forces are H into 2. The load 4 into 2 and this load is 6 into 4. The distance is load into distance. This load is 4 into 2, 4 into 6. The total distance. We get the values of 8 Re minus 2H equal to 56. The moment about C equal to 0. So Re into total distance is 4 minus H into Y. Y is rise is 2.25 minus 4 into 2 equal to 0. So 4 Re minus 2.25 H equal to 8. So find out the values of RAV equal to 3 kilonewton. So segment is AB. The consider equilibrium at the left of the point P. RE into 2, RA into 1.5 plus YB minus 2. So YB equal to 0.875 meter. So L length of the AB, L equal to root of 2 squared plus 1.5 plus 0.875 minus 2 whole squared. That is for length of the span equal to 2.035 meter. So tension at the AB 16 into 2.0 divided by 2, 16.28 kilonewton. So span of segment BC, the length of the span equal to 2.0039 meter. Tangent of BC equal to 16.03 kilonewton. So segment of CD equal to applying the general cable at the point of D, 16 into YD equal to 7 into 2 YD equal to 0.875 meter. The length of the cable of root of 2 squared plus 2.25 minus 0.5 and 0.875 whole square 2.18 meter. So 10 to the CD 16 to 2.18 divided by 2 70.46 kilonewton. The segment of D equal D length is root of 2 square plus 0.5 plus 0.875 whole square 2.42 meter. Tension is the tension of the TE 19.42 meter. So the total distance as AP length BC, CD, and the length is covered to the span. So next one is cables. Cable is subjected to uniformly distributed load along the horizontal span. So shape of the cable, let ABC shown in figure. The flexible cable supported and loaded as shown in figure. The lowest point of the cable P, the selected as the origin of O, the coordinates axis, a free body diagram of the portion of the cable immediately to the right of the portion B, shown in figure. The horizontal tension the cable at B is denoted by TB and the tension at any other point of the P into X into Y and P TP. So now the horizontal force equal to force of the x equal to 0, force of y equal to 0, TP cos theta equal to TP, TP sin theta equal to QX, tan theta equal to QX divided by TP, dy by dx equal to tan theta. So y equal to QX squared divided by 2TP plus C. That is y equal to QX squared divided by 2TP. So this is the tension of the cable T equal to root of BB squared plus H squared. Length of the cable span LS equal to the final values are LA plus LC. So A plus B plus 2FA squared divided by 3A, 2FC squared divided by 3B. So this is the length of the cables. So elastic stretches of the cables. When a cable supported to a load, it undergoes an elastic stretch, which is often of the importance of determining the cable's tags and also the other purpose. By definition of the modulus of velocity equal to F by A divided by already find out the values are equal to stress divided by strain. So stress is equal to load by area. So strain equal to change in length divided by original length. So F by A divided by change in length divided by original length del L divided by L. So del L equal to FL divided by AU. So now elements of the cable of length DS is subject to tension T. So it because the convenient method of determining the elastic stretch of a cable consisting in the first determining DAB, while a definition of the will be taken to the average tension which we apply to the throughout the length of the cable will causes the same total elastic change of length of the actual occurs. It can be expressed in the term of the pitch in the cables, stretch of the cables. For examples, a chain weighing 2 Newton per meter suspended between the two poles with the same elevation. The space is 6 apart. The full of the chain of the poles is 35 Newton. Determine the sake under the length of the chain, assuming the weight to be uniformly distributed along the horizontal axis. Substituting the values, Q equal to 2 Newton per meter, A equal to 6 divided by 2, 3 meter, dA equal to 35 Newton. dA equal to QA root of 1 plus A square divided by 4 FA square. So TA values is 35 Newton. So substitute the values of 8 equal to 2 into 3, root of 1 plus 3 square divided by 4 FA square. So FA equal to 1.7 meter. So FA divided by A equal to 1.7 divided by 3 equal to 0.6. So LA values is A into 1 plus 2 by 3 FA divided by A whole square 2 by 5 FA divided by A whole power 4 plus 4 by 7 FA divided by A whole power 6 plus etc. So LA equal to A equal to values of 3. So LA equal to 3 into 1 plus 2 by 3 into 0.6 whole square minus 2 by 5 2 by 5 into 0.6 whole power 4 plus 4 divided by 7 into 0.6 whole power 6. So for the find out the values of 3.645 meter for half of the chain LC. Therefore, the total length of the chain is 2 LC equal to 7.29 meter. So this is the uh, length of the span of the length of the chain. So next one is a cable carries a load 2 kilonewton per horizontal meter as shown in figure. The left support is lower than the right support by 3 meter. The shaft measured from the left support is 3 meter. The supports are 46 meter apart. Determine the minimum and the maximum tension in the cable and the length of the cable. This problem assume A is support, A is right support, and the C is left support. F equal to 6 meter, F equal to 3 meter, Q equal to 2 kilonewton per meter. So A plus B equal to 46 meter. Find out the values of B equal to 46 minus A. So the shape of the cable, Y equal to Q x squared divided by 2T. TB equal to Q x squared divided by 2Y. So segment of the AB, DBA equal to 2 into A squared divided by 2 into 6. So find out the values of segment of BC, TBC equal TBC 2 into A values is 46 minus A whole 2B divided by 2 into 3. So B value is 46 minus A whole square. So find out the values equating the TBA equal to TBC. So this is TBA, this is TBC. So equating the values of find out the values A squared equal to 2 into 46 minus A whole square 2 into 46 minus A whole squared formation of A minus B whole square. So A squared minus 2AB plus B square. So these values of 4,232 minus 184A plus 2A squared. So the formation of A squared minus 184 A plus 4,232 equal to 0. So find out the values of EA minus B plus or minus root of E squared minus 4AC divided by 2. I'll leave the values of find out the values of A equal to 27 meter. So substitute the values of B equal to 46 minus A. A values to substitute the 27 meter. So find out the values B equal to 19 meter. So A plus B equal to 46 meter. So substitute the values of dA and dB. dA equal to QA root of 1 plus A squared divided by 4 FA squared. So find out the values of dA equal to 130 per kilometer. Tension at support C, T is equal to 2 into 19 root of 1 plus 90 squared divided by 4 into 3 squared. So find out the values of 126 kilometer. So the finally values LA plus LC equal to, so the substitute the values of 27 1 plus 2 by 3, 0.22 whole square 2 by 5, 0.224 whole power 4 plus 4 by 7, 0.22 whole power 6 plus etc. So next one is 9 plus 90, 1 plus 2 by 3, 0.16 whole square minus 2 by 5, 0.16 whole power 4 plus 4 by 7, 0.16 whole power 6 plus etc. So for the finally values of length of the span, 47.19 meter. So this is the length of the cable of the suspension bridges, maximum and minimum values of the tension in the cables. Mm, that's all. So any queries? Oh, okay, thank you.